guys, welcome to the practical section on bash scripting for molecular modeling. I'm Shedrack Eze and I will introduce you to basic commands on using bash. So before we started, this video is specifically for Windows users. If you're using Mac, you already have a bash terminal, and then if you have Linux natively installed in your laptop, then you're free to go. But if you're using Windows, one of the methods one of the easiest method is to use a Windows subsystem for Linux, WSL. I'm just going to show you how to install it. It's actually very easy. So you run WSL, install, and then you wait for it to download and install. Now, because I've installed this before, I'm not going to allow it to run, so I'm going to cut it off. Now, our WSL is installed. It will prompt you to do some commands like set your password, your sudo password, and some other things. But those things are very basic. You can follow the instructions and get them installed. So I'm just going to go right on. So you've already installed your Linux, and then it is open like this. So as I mentioned, opening your Linux bring you to the home directory or the home page, whatever you want to call it. So this is usually represented by the tilde sign, as you can see here. So this is the home, and then as we're going to see, the root directory is still further down. We're going to see that. So the first thing to look at is let's first of all look at where are we. Remember, directories tell us where we are. What is the exact path to get to where we are? Starting from the root or starting from any other directory, any other folder, it can lead us to where we are. So let's look at that first. Print working directory. So it says, oh, you are in home, Shedrack. That's actually my name. So this is where I am, and this is my apps. Every time you run print working directory, it gives you the absolute path. Why? Because it's starting from the root. The root is already slant sign. So how do we get to the root? Let's find out. So you get to the root by changing directories. So you move from one directory to another directory, from one folder to another folder, from one file system to another file system. Change directory cd. So cd /c. We are in the root, right? So that's exactly, so this is where everything starts. All the system file, configuration files, everything are loaded here. So let's get back to our home, and then let's see what it looks like. Okay, so we're back in our home. Tilde sign, slant, forward slant, sign, whatever works. Okay, so let's move on. What are the contents of my file? Now, before I display that, I want to enter a specific folder that I've prepared for this tutorial. So it's the demo folder. So good. Now, I want to explain something to you. This slant line you are seeing here doesn't mean root directory. Slant line is used, it represents root directory, but it's also a separator. Now here, as you can see in this part, the forward slant line started the path. So obviously it is the root because it is not separating anything. But at this point, it is no more root because it's now a separator. It's separating home from Shedrack. So I want to be in mind. So this doesn't mean root directory. It simply means a separator between the home and the demo. So the demo is inside the home. I just entered the demo. So let's find out what are the files here. So we are going to list our directory ls. So you're going to see, so these are the files in my system. I mean in the folder where I am, right? So that is ls. This is the listing command. Okay. Now there are other variation of ls. One of them is ll. Now ll what LL does is to list the whole content of the file with the details. So as we're going to talk later, you're going to see the permissions of the file. You are going to see who owns it. You're going to see the size of the file. You're going to see the date and the time. And then you're going to see the names of the file, including their extensions, right? So LL is an abbreviation for ls minus al. So that's actually what it is. It is a pointer to this particular command. So if you have ll, I think it usually comes pre-compiled, or you can put it in your bash rc file and then source it again. Refresh, it will work. Okay, now there are two important things I want to show you here, as you can see. So there are two extra things here. There's a full stop here, and there is a double full stop here, right? Full stop and a double full stop. Now, as I explained during the tutorials, a full stop always points to the current directory. Watch, cd full stop. I didn't go anywhere. I am where I am because the full stop points to the current directory. Now, what is the double full stop? The double full stop is a pointer to the previous directory. It is taking you one step back. So if I run cd, you see, I have left demo and I am back in the home directory. So that's exactly how to navigate backwards. Now, how to go backwards is to call where you are going. I'm going to demo, so I'm now in demo. But to go back, you don't need to call any name. Oh, I just want to take one step backwards, cd double, then that's it. So these are the ways that you can list the files in your directory, navigate your directory, cd or whatever. So now I am in the home directory. Let's find this library that is inside demo. So I'm going to go cd, right? Demo library, then I'm here. So that's exactly how to navigate through your files. Okay. Now, one other thing I have to say, for each command, you can actually learn more about how to use it, right? For example, I just talked about ls command. How do you learn more about each particular command? The man function is used. It stands for manual. So if I run man ls, it's going to pop up a page that I can browse and see all the possible options that can be used with ls, all the possible things ls can do. So the same thing happens with man cd. Sorry, there's nothing for that. Okay, now let's make some progress. Now let's talk about how to copy your files, right? Now we are in the demo directory, right? So we want this blast.in, want to bring it to Siga folder. Remember, you can only copy a file into a folder. You can't copy a file into a file. It's a file to a folder. You can also copy a folder to a folder, but surely there must be a container. Consider a folder as a container, so there should be a destination for it, right? So we want to copy blast.in into Siga. So cp, remember we say, where is the file originating, the source and the destination? Very simple. So because blast is inside demo, so it is where we are. So no need. Blast.in. Where is it going? It's going into Siga. So Siga. Then that is all. So what is inside Siga? Let's see whether blast was there. So we list the contents of Siga. And then, blast is already there. So this is how to copy a file. Now, what if we want to rename a file, right? We want to rename a file. So let's rename crash.sh. This is a bash file. We want to call it crash not crash. Let's call it not crash.sh. So how do we rename it? We rename it using the move command. Remember, a move command is a command that takes a file from its current position to another folder. So maybe we'll demonstrate with the move command first before we talk about renaming a file. So let's look at it. So we want to move crash.sh into Siga 2. So mv crash.sh, move it into Siga. Now, what you are going to realize is that crash.sh has disappeared from demo. It is now inside Siga. So we can also move it back. Move Siga crash.sh, bring it here because full stop is always the current directory. And then, oh, crash is back. Now, let's go back to the renaming. We want to call it not crash.sh. So move crash is here. Move crash to where? To where we are again, but with a new name, right? Not crash.sh. Then you see it's gone. The name is now not crash.sh. That's exactly how to rename your file, right? So I want the name to be back because that's an important file for me. So I need the name to be back. So you rename a file by moving it from where it is back to where it is with a new name. So it's logical, right? So now this is how to copy and move around your file from one point to another point. So let's do another extra demo. So let's go into Siga again. Now, how many things are in Siga? There's only two things, blast.in and subfile. So let's move subfile back into demo. So we just demonstrate forward moving and backward moving. So how do we do it? CP subfile is in the Siga and we want to take it into demo. From Siga to demo is one step back, right? So double full stop slash. So just move it one step backward. Then I will also go back to find it. Then subfile.txt is here. So this is exactly how to move around your files, right? So the next thing is, how do we create a new file? You're on a Linux terminal and you need to create file. So first of all, we'll look at creating file folders, then we'll look at creating files. So let's make a new folder, tutorials. Let's just call it tutorial. So how do you create a folder? The make directory command is the command useful for creating a folder. Not a file, a folder. So we are going to call it tutorials. And oh, tutorials is already here. We just made a folder. Next thing, how do we delete it? To delete a folder, we use the remove command, rm. Now, because it's a folder, there is a checkpoint on it. I mean, yeah, there is a checkpoint. So you cannot just remove a folder. You need authentication. Now, if you do remove tutorials, it's going to tell you no, it cannot remove it because it's a directory. Now we need to force it, right? Remove minus recursive or minus rf, then it's going to abolish the tutorial. So if you want to learn more how to use remove, you can always man the rm command and then you can see how to use it more. Okay, so that is for folder. Now let's look at how do we create a file. To create a file, usually you touch it. I'm not sure whether I have touch installed. I'll try. So if you touch a file, it automatically creates a file without any other action. For example, you write touch and I want to create tutorials.sh. This is not a folder. This is now a file. It's an extension. Sorry, I forgot a C. Now, if I touch this, it creates a file called tutorial.sh. I'm not sure whether it's going to work because I'm not sure I have touch installed. Oh, it worked. Now, it's going to create tutorial.sh, but the tutorial is empty. So that is one way to, so you can easily create a file by just touching it with the extension or whatever. The other ways are to first of all visualize the file, even though it does not exist. Then you can save it. For example, let's create another one, master.sh. So I'm not going to touch it. I'm just going to write masters.sh. And it opens while it is empty. There's nothing inside it. The file doesn't exist before. Then I'm now going to save it, colon, write, quit, WQ. Then, oh my God, masters.sh is here. So That's what another way to create a file. So you can use vi, you can use nano, you can use, I think, gedit. There are so many of them that are available. Some of them need you to first install them, but vi and nano, I think, are pre-compiled with the Linux. So this is how to create your new file. Okay, now let's now look at how do you look for patterns. I mean, how do you select patterns inside your file? How do you select patterns inside your file? So we're going to take a file here, pu22. So this is a PDB file of a DNA quadruplex. So we're going to look at it first. So let's visualize a file, pu22. So it's just downloaded from RCSB, Protein Data Bank, contains a lot of rubbish, not necessarily rubbish, but we don't need them, right? Then it now has, before it now starts telling us, oh my God, before we now get to where is our DNA exactly, there's so much information. Then we'll now go to the section model 1, right? Then we'll start talking about the DNA. This is where actually start, because it has to start from the atom section, right? If you are conversant with PDB. So now the question is, what if I'm interested in only finding the PDB, I mean the exact part of this file that correspond to the DNA, because most of the other things are informations, just informations necessary for the crystallographer to tell everything about the protein. So what do? I use grep. I'll grep atom, right, from pu22. Now I have to teach two commands at the same time. Now that I've grepped it, if I press enter, it's going to display it on my screen, which I don't want. But let's just do it first, then I'll tell you what I want to say. So if I grep it alone, so it's only going to collect the atoms for me, as you can see here. So all those dirty lines are gone, right? Very easy. So this is one good way to clean your protein. If you download a protein from PDB Bank and you don't have a visualizer, you don't want to use Chimera, Pime, or whatever, so you just know the section you want, you select the atom section and collect it out, send it to another file, which I'm going to explain very soon. Then you have your protein cleaned, no water molecule, no ions, everything is clean, right? Okay, so now this is what I want to, this actually, now, but the thing here is, this just print variables. Variables means it's on the screen. It's not useful for us. If I close this terminal, nothing happened. Okay. Now, what if I really want only that section to be inside a file on its own? So we now enter another command, which is the piping command. Piping command simply means if you have an output from a command, can you send it into a file? Can you send it to another command? So these are the piping commands. So let's repeat the command. So this time around, we're going to grab atom, but instead of printing its variables, we are going to send it to another file. So how do we do it? A greater than sign. So what do we do? Say, clean pu22.pdb. That's all. So if I write clean, I only have the, okay, it also collected some extra lines because those lines also have atoms written to them. But generally, I just have the clean atom file, which is my only PDB. All those unnecessary information are. So if you have a protein, there is crystallographic water, there is ions, you can just grab the section you want. And usually, the section of the protein is presented by atom. If it's a ligand you want, it's presented by heteroatom. You can always grab it, and that's how to clean your file. So this is one way to create a file. Now, this is greater than sign. There's another command which is double greater than. Now, if you use double greater than, you can append. So now you can append information to an existing file. Now, greater than sign creates a new file and append information to it, right? Now, but if you want to add extra information to the file, right? I want to grab not atom again now, but I want to grab heteroatom. So let's do it. I want to grab het atom. I want to grab het atom and then still append it. You know what I mean by append? not replace now, but where the file ended, continue. If I want to append it to clean, if I use this greater than sign, it's going to overwrite it. So I will need the double sign, right? I'll need this so that I can append the heteroatom into this. And that's actually how it works. So greater than sign, double greater than sign, if you already want to create pipe to a new file, or you want to, you want to append. So any of them can work. Okay, so these are just some ways of piping command. Now let's talk about other ways of piping command. What if I want the output of one file to become the input for another file, right? I don't know whether you get what I'm saying. I mean, the output of one file to become even possibly a command for the next file. What if I want to create a new file and rename it at the same time in the same command, right? So I will touch a vida.py file, which is going to create it, right? But I also want to rename it at the same time, right? So I will need the piping command, right? Good. So this is the piping command. It's just a line, right? A vertical line. So I've touched the file and I want to rename it at the same time. Move vida.py to vida.sh at the same time. If I press enter, it works. If I look for vida.py, I won't see it again. What I'm going to have is vida.sh. And why is that possible? Because I can run multiple commands one after the other. Remember here, I was able to create vida, then I now use that vida as the input for the next command. So that's actually how it works. You can use the output of one command as an input for the next command by using piping function. Or there are other kinds of ways you can do this, right? Not necessarily as an input, but to link up your command. For example, you have series of commands that you want to run one after the other. For example, here I can repeat the same thing by touching vida.py and then running double ampersand. So it simply means, create the vida.py file and then do the next command. So it will still work the same way. Now, so both of them works depending on the context. So you can use either of them. Okay. Now, so that is what we have for now. So let's move ahead. Let's move ahead to talk about, so if you have your screen clustered, you can actually look at the clear command and everything goes. So it just hides it because, everything goes, and then it looks as if you're starting afresh. So let's talk about file permission. Now, I mentioned that when you run ll, you are going to see this first parts of the first column of information, which is the file permissions. This tells us what are possible with the file. First of all, if it's a directory, it starts with a D. If it's not, if it's a file, then you press with a dash. Then you have the read write, execute, read write, execute. So these are the levels of permissions possible. So, and I want us to demonstrate this by looking at, this is vida.sh, ll vida.sh. We can see here, read write for the owner, that's myself. For others, read, no execution. So if this is really a bash file and I want to execute it, I'll need to give it some execution capabilities. So chmod, as I described in tutorial, +x vida.sh. And then I look at it again. It has an asterisk. It has execution command, both for the group user and the individual user. So you can see everyone can execute it depending on the level of permission. So I can still remove the execution powers by doing a minus, and then we are back from where we started. So you can give command. If you also want to give a write command, the same way, +w, -w, whatever, read command, whatever. So these are how to give file permissions to a level of file permissions. Now let's talk about how do you know how much information are in your file. For example, we worked on PU22 before. So how many lines are in PU22? How many words are there? And so many other things, right? So we can look at word count WC pu22.pdb. Oh, it's telling us, oh, we have 153 lines, 12,572 words, 94,000 characters. So it's always in that line. So word count is important because you can use word count to go through your files line by line, locate a particular line, and then use it to collect that line. Okay, so that works. So this is a very small view of how to use bash and the capabilities that are in it. Now, one of the last things we are going to look at before I close this is the wildcards. We mentioned that throughput is important, and that's why scripting, command line language is very interesting because it allows us to do throughput. We can do pattern matching. For example, how many files in this folder ends with a txt or text file? So I can look for them ls every file here that ends with txt, because asterisk means everything else before txt. Then it's going to, let's do ls so that it will list them vertically. So there are 4 files here that ends with TLT. So this is an introduction on how to use how to use wildcards, right? So you can literally do a whole lot of things using asterisks, using $sign, and in the tutorial I provided you a table that shows different use cases for each of the wildcards. So with this, you can parallelize your workflow, you can pass through your file faster, and so many other things, right? So the same way, I can decide to copy all the files that has txt extension out to another folder, and at once all of them goes, right? I don't need to copy them one by one. It's akin to doing, let's say you want to do selection on Windows, but that one is more difficult because you need to personally use your eyes to select all the files that look alike. But here, with the extension, everything goes on smoothly. And then with this, we've come to an introduction to Linux. This is not exhaustive. This is just an appetizer in the basic sense. So many of the links I provided in the course tutorial, you can use that to, especially the resources from Cornell University, you can use that to push your limits on how to script on Bash, and programming will become easy and fun. And this information is necessary because supercomputers around the globe are using scripting languages. Almost all the fastest supercomputers are on Linux, run on Linux. So they don't run on Python. I mean, they have so many Python codes, but all of them are wrapped in Linux because this is the one of the basic way of representing operating system. All right, have a nice day. Kudos to you for coming this far. Bye.